Good morning, everybody, and welcome to another maths lesson. I hope that you are doing well today and you are ready to do some super maths. So, as always, let's begin by seeing the things that we need for today's maths lesson. So today, you are going to need a dry white pen, a whiteboard, or something that you can write on and rub out, pencil and paper, or your home learning book, and one die. Now that is spelt right, because if we have just one dice, we call it a die. If we have two of them, we call them a dice. 2 dice, 3 dice, but one die. And some objects to count. So about, say about 30 bits of pasta or Lego bricks or pebbles or buttons, whatever you've got. So to go and get those things together, I will give you about 2 minutes to go and get them. And I will see you in just a moment when you are ready. See you in a sec. Okay, welcome back everybody. Now, let's get started by warming up our maths brain. And we're going to begin by doing some number sequences. It says, how far can you complete the pattern in 1 minute? So in a moment, I will give you 60 seconds. You can choose which one you want to do. You might want to do the top one, which goes 0, 2, 4, or the next one, which goes 1, 3, 5, 7, and you've got to continue that as far as you can, or the next one that goes 84, 86, 88. So choose which one you would like to do. Your 60 seconds starts now. Okay, you're halfway through, 30 seconds gone. Keep going, everybody. Good work. Just keep going as far as you can. See how many numbers you can get down. Okay, we've got 10 seconds left to finish. 5, 4, 3, 2, 1. And your time is up. Well done, everybody. How did you get on with that? Well, let's have a look at these number sequences. Now, I've continued them a little bit. You might have gone even further than me. So, on the top one, it goes 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and so on. Well done if you did that sequence. And on to the next one. The next one goes 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 30, and so on and so on. Well done if you did that one. And then on to the last one, 84, 86, 88, 90, 92, 94, 96, 98, 100, 102, 104, 106, 108, 110, 100, and so on. Well done with your sequences. Has anybody noticed anything about those sequences? They were all counting in twos, weren't they? But they were a little bit different. The first one, we counted in twos, starting at 0, 0, 2, 4, 6, 8. And all of those numbers, as we know now, are in our 2 times table. There's something special about all of those numbers. Do you know what that is? Well done if you said they are even numbers. So the next sequence, 1, 3, 5, 7, that was counting in twos as well, but we didn't start at 0, we started at 1. And we missed out all of the numbers in our 2 times table. We missed out all of those even numbers, 1, 3, 5, 7. So we were counting in twos, but every number that we landed on that time was an odd number. And then with our last sequence, 84, 86, 88, we were counting in twos again, and they were all numbers in the 2 times table. So they were all even numbers again, but our numbers were just a bit bigger from our starting point. We started at 84 that time. Well done if you spotted that. And in today's lesson, we are going to be thinking about how do brilliant mathematicians recognize odd and even numbers, because we've talked about them a little bit, but today we're really going to start to think about what they are so we can recognize them. So to begin with, here's something for you to think about. We've got two number lines there. If we look at number 1, it says, follow the jumps and count along the number line. What do you notice? And then number 2, follow the jumps and count along the number line. What do you notice this time? So pause the video, count along those number lines and see if you can spot anything. I will see you in a moment. Okay, welcome back. Did you notice anything? Well, let's look at the first one. So if we follow those jumps and count along the number line, 0, 2, 4, 6, 8, 10, 12, 14, 16, we're counting in 2s. And we are missing out the numbers 1, 3, 5, 7, 9, 11, 13, and 15. All of the numbers that we land on, they're all in our 2 times table. They are all multiples of 2, and they are all even numbers. We were missing out all of the numbers in between. We were missing out the odd numbers. Well done if you noticed that. Let's look at the next one. This time we started counting at 1. 1, 3, 5, 7, 9, 11, 13, 15. And we missed out all of the numbers in the 2 times table. We missed out 0, 2, 4, 6, 8, 10, 12, 14, and 16. We missed out all of the even numbers. And that time, every number that we landed on was an odd number. Well done if you noticed that. Now, here are our friends Sunny and Suki. And Sunny and Suki are going to play a game. They are going to hide some shapes around the garden. Sunny is going to be hiding 1 and 3 and 5. And Suki is going to be hiding 2 and 4. And if we look at those numbers, the numbers that Sunny is going to hide are the odd numbers. And the numbers that Suki is going to hide are the even numbers. Okay, Suki, have you got your number 2 shape to hide for us? You go first. Oh, there it is. She's hidden it behind the flowers. That was a good hiding place because we can't see it at all. Okay, Sunny, it's your turn. Could you hide a number for us? Oh, he's got his number 3. He's putting it behind the flowers. Oh no, Sunny, we can still see part of your number 3 sticking out the top. We can still see a little bit. Okay, Suki, your go. What have you got to hide? Oh, she's got her number 4. She's hidden it behind that barrel. Oh, that was a good hiding place. We can't see it at all, can we? Okay, Sunny, your turn. Number 5 behind the barrel. Sunny, we can see a bit of it. That's not really well hidden. We can see a little bit sticking out the top. Sunny, have you got one more number to hide? Oh, he's got number 1. He's putting it behind the plank of wood. It's still sticking up a little bit, isn't it? Ah, Suki did a good job at hiding there, but I think that Sunny's numbers were a bit trickier to hide because they all had a little bit sticking up. All of Sunny's numbers were the odd numbers. Let's have a little look at them a little bit closer. So there's number 1, number 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we can see that some of those numbers on our Numicon shapes have got a little bit sticking up. These ones here, the ones that are wiggling, they've all got a bit sticking up. And all of those shapes have got a hole which hasn't got a pair. Let's just put them down the bottom. So those numbers down the bottom, which have got holes without a pair, are all of the odd numbers. The numbers at the top, 2, 4, 6, 8, and 10, all of the holes have got a pair and they've got a flat top. So all of those numbers with a flat top, which have got numbers in pairs, are all the even numbers. The shapes at the bottom, which have got a hole without a matching pair, are all of the odd numbers. Let's take a closer look at one of those. Let's look at the number 6. So the number 6 has got 6 holes, and all of those holes are in a pair. There's 3 pairs, 3 lots of 2. And if one of those shapes has got all of the holes in pairs, it means it's an even number. So if we can make pairs, that is a way of spotting even numbers. Now here we have got our children. They're about to play a game, and for this game they need to get into pairs. How many children have we got there? Can you count them? 1, 2, 3, 4, 5, 6, 7, 8. Do you think the children will be able to get into pairs for their game? Let's see, shall we? Do we have an odd amount of children or an even amount of children? Because we were just thinking, if we can make pairs, we've got an even number. Let's see. Let's put them into their pairs. Oh yes, they are all into pairs, aren't we? So we had 8 children. They could get into pairs, so 8 is an even number. Oh no, Jack's got to go now. Off you go, Jack. See you later. Now the children carry on playing, and they still need to get into pairs again. This time, because Jack's gone, we've only got 7 children left. Is 7 an even number or an odd number? Do you think they're going to be able to get into pairs? Let's see. Off they go. Well, most of the children have got into pairs, but we've got one little boy left on his own who hasn't got a partner. He couldn't get into pairs. So 7 is an odd number because we couldn't make pairs. Another way of thinking about odd and even numbers is if we can share them equally into 2, and we've been doing some work on sharing and dividing into 2 recently. So here are 5 flowers. Can the flowers be shared equally between 2 pots? Pause the video here. If you want to, you can use your pasta or your buttons and share them equally into 2 groups to see if you can do that. Pause the video and do that, and then come back and decide whether or not 5 can be shared equally into 2. I'll see you in a moment. Okay, welcome back everybody. What did you find out? Well, let's put those flowers into 2 pots. Here we go. 1 in that pot, 1 over there, 1 over there, 1 over there. Oh, but look, we've got 1 flower left. So the flowers cannot be shared equally between the 2 pots, which means that 5 is an odd number. If you can't share it equally into 2, it's an odd number. Now I've got 12 flowers this time. I've lined my flowers up and I've put them on a number line. Do you think the flowers can be shared equally between 2 pots this time? What do you think? Pause the video and have a little think. Okay, what have you decided? Well, if we've got 12 flowers, 12 can be shared equally between 2 pots because 12 is an even number. If we shared it equally, we'd have 6 in each pot. So if you can share it equally, it's an even number. I wonder what would happen if we had 13 flowers. Do you think we could share 13 equally between 2 pots? Here's our number line. Do we think 13 is an even number or an odd number? Well, 13 is an odd number, and if it's an odd number, we can't share equally between 2. What if we had 14 flowers, or 15 flowers, or 16 flowers? Could you pause the video and have a little think if you could share 14, 15 and 16 flowers equally between 2? You can use your counters or your pasta to try and work it out if you want to. I'll see you in a moment. Okay, what have you found out? So if we had 14 flowers, there we go, we could share it equally between 2. So 14 is an even number. If we had 15 flowers, we couldn't share it equally. We'd have 1 left over. So 15 is an odd number. And if we had 16 flowers, we could share them equally into 2 pots. So that means 16 is an even number. So we've thought about 2 ways that we can think about odd and even numbers. If you have some counters and you can put the counters into pairs, they would be even. Or if you could share them equally into 2 groups, they would be even. If you can't do that, they will be odd. So Sunny's been thinking about that, and Sunny says, I know 6 is an even number because I can split 6 cubes into 2 equal groups. Okay, you show us, Sunny. Oh, there we go. He split it into a group of 3 and another group of 3. 2 groups of 3. So 6 is an even number. Well done, Sunny. And here's Suki. Suki knows that 10 is an even number, but she can't split her 10 Numicon piece into 2 equal pieces because it's tough. You can't rip it into 2. But you are right, it is an even number. Suki, let's have a little think about that. Imagine we could draw a line down the middle of our 10 Numicon piece. We could see on one side we have got 5 holes, and on the other side we've got 5 holes. They've all got pairs, so we've got 5 pairs of holes, and that is why 10 is an even number. But we could prove it. We could swap our 10 piece for 10 ones, and then we could split them into 2 groups like that. So we can exchange a 10 for 10 ones, and then we can split them equally into 2 groups of 5. So 10 is an even number. Well done, Suki. So Suki is saying, well, if 10 is an even number, then 20 must be an even number too. Is she right? She is, isn't she? And 30, and 40, and 50, and 60, and 70. So all of the tens numbers, all the multiples of tens are even numbers. Suki is saying, if I add any of these pieces, is my number still even? Well, she's got a 2 and a 4, a 6 and an 8 there. Well, let's see, shall we? So let's see if we had 10 and 2. That makes 12. Would that be an even number? Yes, it would, wouldn't it? Because we can share it equally into 2. We could split it into 2. What about if we had 2 10s and a 4? That would make 24. Is 24 an even number? Yes, it is. And what about if we had 48? Is 48 an even number? Yes. So Suki, you're right. Whichever way you put those shapes together, you will still have an even number. And so on to today's problems. And as always, we've got 3 different challenges for you to do. Now, the first challenge, you should all be able to do this one, finding the odd and even numbers. Then our middle challenge, which most of you will be able to do, is the odd and even number problems. And then some of you might like to try the true or false prove it questions. So let's have a little look at them. So first of all, our first challenge says, use counters to find the even numbers. So you've got to use your pasta shells or stones or buttons, whatever you've got, to try and work out which of these are even numbers. And remember, we can do that by sharing them into 2 equal piles. If you can share them into 2 equal piles, they are an even number. So you've got to use counters to find out if 7, 10, 12, and 17 are even. So just to show you, I've got my 5 pasta shapes, and I'm going to divide them into 2 equal groups, share them into 2 equal groups, one for you, one for you, one for you, one for you. Oh, I can't share them into 2 equal groups, which means 5 is an odd number. So that's what you've got to do with those numbers. On to the next. Oh, you've got 15 minutes for that. Pause the video here if you're going to try that one. Okay, on to the next one. So there's 3 different questions here. So the first one says, use counters to prove that these numbers are odd. So you've got to prove that 17, 13, 21, and 25 are odd. And then you have to complete this sentence, which says, these numbers are odd because, and you've got to finish that. Then the next one, this is where you will need that die, which is 1 dice. It does say roll a dice twice. It should say roll a die twice to make 2 numbers. Are they odd or even? Add them together. Is the total odd or even? So as an example, with my first roll of the dice, I rolled a 3, which was odd, and then I rolled a 2, which was even. And then to find the total, I did 3 add 2, which is 5, and the total 5 is odd. So that's what you've got to do, and you can do that to find about 5 or 6 different examples. And then on to the next one, Sunny makes a pattern. which we've got some missing numbers there. So we've got something, then 5, 7, 9, 11, 13, 15, something, something. So first of all, what are the missing numbers? And then you've got to write two numbers greater than 30 that could be in the pattern. And then you've got to write two numbers greater than 60 that could not be in the pattern. So if you're going to try that one, pause the video here. You've got about 15 minutes to do it. I will see you in a little bit. And then on to our last challenge, the true or false prove it challenge. And there are three statements here that you have got to prove. And you've got to prove them by finding examples, by doing some calculations, some number sentences to show that it is true or false. The first one says, an odd number plus an odd number, that should say, an odd number equals an even number. An odd number plus an odd number equals an even number. So you've got to do a few different number sentences to prove that that is true, or maybe it's false. The next one says, an odd number times 2 equals an even number. So again, do some different number sentences. Multiply some odd numbers by 2 and see if if it always makes an even number. Then the third one says an odd number multiplied by, again, that should say an odd number equals an even number. So again, do some number sentences to prove that that is true or that it is false. So again, pause the video. It's 15 minutes to try it. Off you go. Good luck. Okay, welcome back everybody. Let's go through the answers. So using the counters to find out which of those numbers were even. Well, 7, we can't split the counters into two equal groups, so 7 is odd. 12, we had two groups of 6, so 12 is an even number. 10, we had two groups of 5, so again that is an even number. Then 17, we had two groups of 8, but one left over, so 17 is an odd number. On to the next one. Using counters to prove that these numbers are odd, 17 is odd, 13 is odd, 21 is odd, and 25 is odd. And these numbers are odd because, well, this is what I wrote, you can't share them equally into two groups. You might have written something like that. Perhaps you've written something a little bit different. Maybe you've said you can't make pairs. Okay, on to the next one. Rolling the dice. Now you could have lots of different things here, lots of different number sentences. Here are a few that I did. I had a 5, and then I had a 4. 5 and 4 is 9, which is odd. I had a 6 and a 2. 6 and 2 equals 8, which is even. So hopefully you've got some things like that. And then on to the last question. Sunny makes a pattern. 5, 7, 9, 11, 13, 15. Well, the next numbers would be 17 and 19. Then I can go backwards. 9, 7, 5, 3, and fill in that one. And what do you notice about those numbers? They are all odd numbers. We're counting in twos, but we are counting all of the odd numbers. So to write two numbers greater than 30, which could be in this pattern, well, they've got to be two odd numbers. So you could have 31, 33, 35, 37, 39, or anything else greater than that, which is an odd number. All odd numbers end in 1, 3, 5, 7, or 9. And then the next one, write two numbers greater than 60 that could not be in the pattern. So that's any numbers greater than 60, which are even. 62, 64, 68, 70, 72, 74. So even numbers end in 2, 4, 6, 8, or 0. So you could have any numbers greater than 60. You could have something like 10,432, as long as that last digit is an even digit. And on to the last one. True or false? Well, the first one is true. 1 add 3 equals 4, 3 add 5 equals 8, 17 add 3 equals 20. So as long as you've got a few number sentences, that means about 3 or 4 number sentences to prove it. The next one, an odd number times 2 equals an even number. 3 times 2 is 6, which is even. 5 times 2 is 10, which is even. 11 times 2 is 22, which is even. So again, that is true. On to the last one, an odd number multiplied by an odd number. 1 times 3 is 3. Well, that's odd. 3 times 5 equals 15. Again, that's odd. 7 times 3 equals 21. So every time I do that, I am making odd numbers. So that statement is false. Well done if you found the answers to those. And that brings us to the end of today's lesson. We've been thinking about odd and even numbers. Tomorrow, we are going to carry on with doing some dividing work. So I look forward to seeing you in tomorrow's lesson. Bye-bye.